Tuesday, we talk about a lot of operator, right? We talk about arithmetics operator, we talk about equal, we talk about assignment operator. And at the end, we talk about two special kind of operator, that is increment and decrement operator. And we talk about that for these two operators, they have two types. One is prefix increment, and another is postfix. So we can have the prefix increment, postfix increment, and similarly, we can have the prefix decrement and postfix decrement. So for the prefix, we need to add these two operators before the variable. And for postfix, we need to add the operator after the name of variable. So it will look like this. And we also talk about the major difference between them is when this operation will be executed. So for the prefix operator, it will increment I immediately. However, if you use postfix operator, then the meaning of postfix operator is that for the statements that you use the postfix operator in the same line, that this line will use the old value of I for now for this line, but it will increment the value of I before the next statement is executed. So that is the major difference between them. And also after the class this Tuesday, there are some of you come here and we discuss some more detail about prefix and postfix, increment and decrement. So and I searched online a bit, so some of you think that, some of you have the question about, is there any, so when should I choose prefix and when should I choose postfix? So this is one of the example and answer here. So the best practice is use postfix operator only when necessary. So the postfix operator will increase the will decrease the efficiency of your program a bit because it requires computer to do some extra works. So try to avoid that. But in some situation, if you really need the postfix operator, I think you can use it without problems because our computer nowadays are really powerful. So this slightly little work doesn't really affect the efficiency of your program. So if you are curious about more about the comparison between prefix and postfix, I will recommend you can search online or you can discuss it with generative AI to learn more. However, for this beginner's course, okay, the mic is a bit weird. Okay. So for this beginner course, I don't want to give you guys too much detail about those two things because those details doesn't really matter if you are the beginner. So, but if you are not a beginner and you really want to know the details, you can search online. So the next question is, does this increment and decrement operator work with float variable? Because in the previous example, we only apply these two operators on integer variable. However, can we also apply these two operators on the float variables? So yeah, you can see the answer here. The answer is yes. We can also apply these two operators to the floating point number, and we can also apply it to the float variable or double variable. It can also increment or increase the floating point number by 1. However, it's weird to increment or decrement a float variable. So not many people do that, but you just need to know that we can do that. So here is the complete table for all the operators we teach today. And you can see in this table we add precedence and associativity here. And please just have a rough ideas about the precedence of different operator here. And also have some memory about the associativity here. So for all the, okay, so here I forgot to add the name of the other operator here, sorry about that. So in this line we have multiplications, division, remainders, and here we have addition and subtractions. And we also talk about the compound assignment and assignment rights. And you can see the compound assignment have the lowest precedence compared to other operators. So for the next topic or the final topic of this chapter, I want to talk about how can we know a complex expression are evaluated. So evaluated means that we run these statements or the statement is executed. So after knowing this table, actually we can use this table to add the parentheses to this expression. So I will say this expression is not common in the real life because you can see it's really hard to understand, right? And there's definitely a better way to rewrite this statement because this is very hard to understand. So this statement just for you to practice this table here. You can practice how to compare operator with different precedence and associativity. So you can try to add the parentheses to this statement by yourself based on the table here, and you can go to this slide to check out if you got it right. But again, I don't recommend you writing this kind of statements in your NEC program. Okay, so the next topics we're going to talk about if we have a more complicated statement, we can actually divide this statement, this expression into different sub-expression, right? So this is entire expression, but in the long expression, we can actually divide them into small parts. So those small parts are called sub-expression. So the value of an expression sometimes depends on the orders in which its sub-expression are evaluated. So C itself don't define the order of which sub-expression should be evaluated first or not. However, these rules only apply to the expressions without logical operators. Because if these expressions have a logical operators, the way the order of evaluation will defined. But we haven't introduced the logical operators, so I will talk about this in the later slide, in the later course. However, for now, if one expression only have arithmetic operators or compound assignment operator, then we cannot know in this example whether this sub-expression is calculated first or this sub-expression is calculated first because C don't really define the order for this situation. However, you can see that in this case, in the example here, the order of evaluations doesn't really matter, right? Because if we calculate this sub-expression first and then calculate this sub-expression first, the outcome will still be the result of the first part multiply the result of the second part. So in this case, it is fine. However, so what I say is that expression have the same value no matter the order in which their sub-expression are evaluated. So you can see another example here. In this example, we have an expression like this, and we store the result of this expression back to I. So this expression have the same format as this expression we saw in the previous slides here. And you can see no matter the first sub-expression is evaluated first or not, the output value will still be 2 multiplied 3. So in this case, we don't really need to care about the order of sub-expression evaluation. However, there are some situations the order of sub-expression evaluation will change the return value of the entire expression. So let me show you the example here. So in this example, you can see we have let's assume that A, B, C are integer variable, and A we assign it to 5, and then we want to assign the return value of this entire expression to C. And let's check out this expression more carefully. You can see we can divide this long expression into 2 sub-expressions here. So the first sub-expression is we assign the return value of A plus 2 to B. And the second sub-expression is that we assign 1 to A. So in this case, if the first sub-expression, this expression is evaluated first, the result of C will be 6, right? Because the value of B depends on the original value of A. However, if the second sub-expression is evaluated first, we will assign 1 to A first, and then we will add the new value of A by 2, so the result will be 3. So that is why if the second sub-expression is evaluated before the first sub-expression, then the result will be 2. So in this case, you can see that which sub-expression is evaluated first will influence the return value of the entire expression. So that is why I want to say that please avoid writing this kind of expressions. So please don't access the value of variables and modify the same variable in the same expression. So please try to avoid writing something like this. Also, it seems like you can complete a lot of complicated calculation in one line. However, if we write something like this, it is really hard for us to know what is the certain value of C, what is the result of this expression. So instead of writing something like this, I will recommend you to just break all the expression in separate line, because for C, the first line will be definitely evaluated before the second line, before the next line, right? So, and also please use only one assignment operator in one statement. Don't use like 3 assignment operators in the same statement. So the statements like this, well actually, so the statement like we use multiple assignment in one statement will cause undefined behaviors. The reason is that we don't know the exact behavior of this expression, right? So, and again, I found this meme online. So if you still remember, if you divide something by 0, you will also cause your program to have undefined behaviors. And undefined behavior is bad, and we should avoid that. And the reason we should avoid undefined behavior is that undefined behavior will cause the following effects, and those effects are not good for our code and computer. So the first thing that will caused by undefined behavior is that your program might behave differently when compiled with different compilers. So you have the same code, but your teammates use C-lens and you use GCC, then there's high chance that the outputs of your code are different if you have undefined behaviors in your code. And the second possible consequence is that your program may not compile in the first place, and so that is the time you need to debug and correct your code. And the third effect is that if the compile may not run, if it's okay. And the third effect is that if you pass the compilations and you want to run your programs, and if your program have undefined behaviors, your program may not run at all. And the fourth consequence is that if your program can run, however, your program may crash or produce meaningless results if you have some undefined behaviors in your code. So none of these consequences is good, so please try to avoid to make statements that will produce undefined behavior. So that is all for this course for the expression. So in these lessons, we talk about this operator, we talk about arithmetics, assignment, operator, we talk about the concept of precedence and associativity. We talk about assignment and the compound assignments, and then finally we talk about increment, decrement operator. And at the final topics of this lesson, we talk about the importance to understand how your expression is gonna be evaluated. So please try to avoid programs that produce undefined behavior. And today, our plan is to talk about selection statements. So after knowing all these operators, you are ready to learn selection statements. So today we have two topics here. To use selection statement, you need to learn another 3 types of operator. That is rational, wait, that is relational. Okay, I didn't notice, I typed it wrong. Relational, okay, sorry about that. So to learn how to use selection statement, we need to know how to construct, how to write logical expression. And to write a logical expression, we need to know how to use relational, equality, and logical operator. So far, we have used return statements and expression statement, right? So the return statement is the return 0 you always need to have at the end of your main function. And the expression statement is the statement we introduced in the previous lesson. That is the expression that have arithmetic and assignment operators. So something like this, I label in blue. So these 2 lines are all expression statements. So actually, most C statements can be classified into 3 categories. So the first categories of the statement is selection statement. So that is the statement we're going to introduce today. So in the selection statement, you will see these 2 types of the statement, that is if statement and switch statement. And the second kind of the statement is iteration statement. So iteration statement are the statement that can help us to build loops. So we can do the while loops, do loops, or for loops. And we will talk about that in next week, I think. So that is an iteration statement. The third statement is jump statement. So jump statement can allow us to jump to the different points, different line of our code. So if we want to use jump statement, we might use the break, continue, and go to. And actually, return statement is also belongs in this category, jump statement, because return statement can help us to jump from the functions where the return statement is in. So if we write down the return statement at the end of the main function, when we run this return statement, our program will jump out from the main function. So that is why our program will end if we run this return statement inside the main function. So of course, there are other different kind of C statements. We have compound statement, we have NOR statements, but we will talk about them when we encounter them. But now you just need to know, for the most of the C statements, we can classify them into these three types. And today, we're gonna focus on selection statements. So just like I said in the previous slide, to use selection statement, we need to know how to build logical expression first. So what is logical expressions? So when we use some statements, a lot of statements will require us to test value of expression to see if the value is true or false. For example, in our code, we might want to determine whether the age input by user is over 18 years old or less than 18 years old, so that we can know whether the user is adult or not, right? So in our code, we often encounter this situation that we need to determine whether certain condition is true or false. And also, like in the mathematics, we can also use C to describe. In the mathematics, we sometimes will also compare whether this value is larger than the other value, right? So in C, we can also do the same comparisons. So we can write down the expressions to describe the relationships or the comparison like this. Whether J is smaller than, whether I is smaller than J. So in C, if we write down the expression like this expression will produce a true value that is 1 if I is truly less than J. So let's assume that I and J are two integer variables. So if the value of I is less than J, then this logical expression will produce true, because yeah, this is true, I is smaller than J. However, if I is not smaller, is not less than J, then this expression will produce 0. And in C, if a logical expression returns 0, that means that it is false, this condition is false. And if this condition is true, it will return 1. So how to write this mathematic expression in C? So to write this, we need two kind of operator, that is relational and equality operator. So first, let's check out the relational operator. So this is the table of all the relational operator. You can see the symbol is pretty much similar with the symbol you use in the math, right? So this is called less than, and this is greater than. And if we add the equal symbol right after these two arrows here, this is less than or equal to. And this one is greater than or equal to. So again, this relational operator will produce 0 or 1 when we use them in the expression. And again, 0 represents false, 1 represents true. So let's check out the example here directly. In this example, we can see we use the relational operator to compare integers and floating point number. And in this case, we can even compare floating point and integer number at the same time. So it is okay if you mix the type when you use the relational operator, because the purpose of the relational operator is to produce true or false. So in this case, we have the integer variable I, and in this case, I want to assign the return value of this logical expression back to I. And what this logical expression want to do is to check if 1, this is 1, not I, sorry about that. So if 1 is smaller than 2.5, because this symbol is less than, so we want to know whether 1 is less than 2.5. And the answer is obvious, right? So that is why this condition is true, because 1 indeed is less than 2.5. So the return value of this expression will be 1. So if we print out the value stored inside I after this line, then the value stored inside I will be 1. Then let's check out the second line here, the next statement here. So in this statement, I want to check if 5.6 is less than 4. And obviously it's not, right? So this logical expression will return 0 to represent this condition is false, then store the return value back to I. So after we finish the third line here, the value stored inside I will be 0. And whenever we talk about operator, we need to know their precedence compared to other operator. So the precedence of relational operator is lower than the precedence of arithmetic operator. And the relational operator also have left associative. So that is why if you check out, if we have an expression like this, like the first line here, you need to know that you should know what this expression will do is to calculate the arithmetic operator first, and then compare the results of these two sub-expressions, because the relational operator have lower precedence than arithmetic operator. And if we have something like this, you can see we have two less than relational operator. Then if we have something like this, we need to remember for the relational operator, they are left associative. So we need to put the parentheses start from left to right. So this statement is actually look like this. So this sub-expression will be evaluated first, and then we will evaluate this operator. However, maybe some of you might think that, okay, this second statement looks a bit strange. So why it is a bit strange? So let's check out the second statement more carefully. So although if you write this statement in C, it is legal statement, but it might not do the thing that you want it to do. Because in the mathematics, if we write down something like this, what we want to do is to test if 10 is less than 15 or it is larger than 5, right? This is what we can represent these meanings in the mathematics. But that is not true for C. If we write down this expression in C, it does not test whether 10 lies between 5 and 15. What this expression will do is that it will evaluate this sub-expression first, So what this sub-expression will do is to compare 5 with 10 and to see if it is true. And of course, 5 is smaller than 10, so this sub-expression will produce 1, will return 1 to say it is true. Then we will continue to evaluate the second relational operator. And since the return value of the first sub-expression is 1, so what we actually do is to compare 1 with 15. We want to compare whether 1 is less than 15. And of course, the outcome is true. But you can see that it is not what we want this expression to do, right? Because what we originally want this expression to do is to test whether the value I put in the middle here is within the range between 5 and 15. But you can see if we write down this expression directly like this, what we do is not what we wanted to do. So to achieve what we originally want our C code to do, we need to revise this expression from this into the second line, that is here. So in C, that is the correct expression to test if 10 is larger than 5 and less than 15. And we need to use the 2 double AND here. And this AND is a logical operator. We will introduce it in the later slide today. But before that, let me introduce the equality operator first. So we can use the relational operator to check whether one value is larger than or smaller than the other value. So how about checking if one value is equal to another value? So to do that, we need to use the equality operator. And there are just two equality operators. The first one is equal to, and the second one is not equal to. So if we want to use not equal to, we just want to add this mark instead of the equal mark. And again, the equality operator will produce 1 or 0 to indicate whether this comparison is true or false. And all the equality operators have lower precedence than the relational operator. So if we write down the statement like this, we have equality operator here in the middle, right? And we also have 2 relational operators in the 2 sub-expression here, like this. So C will interpret this statement like this statement that I put it in the second line. So it will evaluate whether I is smaller than J first, and then whether J is smaller than K first, and compare the return value of these 2 sub-expressions. So let's check out, okay, I forgot, we don't have Slido today because I cannot, I can connect to CCU actually. Do you guys want to check out the Slido? Let me see if I can start a Slido. Oh, okay, it's weird. I think I connect to the Wi-Fi from the other meeting room, but I think the internet is not strong, it's not good enough. So don't worry, we'll check it. So please think about the result here by yourself. And if you know if you know what we taught in this slide, you should be able to know what is the return value of these 2 expressions, of this expression. So let's continue. So the next slide, so the following slide, what I want to introduce is the logical operator. So the logical operator can help us to compare more than 2 things, because some process in our code only allowed a spatial condition, right? For example, in our code, maybe this group of statements, we want this group of statements to be evaluated only in the situation where j is larger than and less than k. So how can we how can we write down the code to represent this situation? How can we use our C code to test whether j meets this requirement? And for example, we can also use C code to determine whether the age input by user is more than 20 but less than 65. So to achieve these two evaluations, we need to test more than two things. So to do that, we need to use logical operator. And you already saw this operator in the previous example, but now I'm gonna explain more about this logical operator. So we have three kind of logical operator, and the symbol of them look like this. So the first logical operator is logical negations, and it is a unary operator, so it only has one operand. And this is the example of how we can use the logical negations. So if we add the logical negation in front of a true value or a true condition, a condition who will return true, then the result of this case will become false. Similarly, if we add the logical negation to a return value that is false, then the return value will be true. So logical negation, basically what it do is to turn true to false, false to true. And the second logical operator is logical AND. So you can see this is a binary operator, so it requires two operand. And the usage case of logical AND is like this. So you can see if true and true, it will be true. However, if we have false in one of the operands, the result will be false. And don't worry if it is too complex, if you cannot understand why it looks like this, don't worry, we have more explanation in the later slide. Here I just want to show you the three logical operators in the same table. Okay, and the third logical operator is logical OR. It is also a binary operator. So you can see we also have two operands here. And you can see for the OR operator, whenever there is one operand that is true, the result will be true. So how to understand that? How we can so it is impossible for you to check out this table every time if you use AND and OR. And I would say this is very important for computer science students to understand why false and false is false, and false and true is false, and to understand why false or true is true, because you will also use this concept in the other course. So I want to spend some time to really explain this. So how can we understand this? So I think about a real life example which might help you to understand the logic behind AND and OR. So let's assume that my mom or your mom told you that please buy me an egg, and we have and here, and vegetables. So that is the instruction, right? So if this is the instruction, and if I buy like the seafood and meat, then these two things are false based on the instruction I got, right? Because the instruction need to be egg and vegetables. But here we have two false, so the result will be false. And if I buy a meat and a vegetables, the meat part meat is not egg, so the outcome is that this is false. And I still buy the vegetable here, so the vegetable meets the requirement here, so this is true. However, your mom is still not happy here because her instruction is egg and vegetable. So you need to get two things right. So this is still false. So the only answer is that you need to buy an egg and vegetable. So only the condition where two operands are true and true will be true. So let's check out the similar example for OR. So again, your mom have instruction for you, and today the instruction is that your mom wants you to buy an egg or vegetables. So if you buy the seafood and meat, both things are not the things your mom wants you to buy. So the outcome will be false. Your mom will be unhappy. Then you go to the supermarket for the second time, and for this time you buy the meat and a vegetable. And because your mom's instruction is you can buy the egg or a vegetable, so you meet one of the conditions. So your mom will be happy in this case because you buy vegetables. So false or true will be true because at least one is true. And finally, if you buy an egg and vegetables, both things are true, then true or true will be true. Okay, so I hope this real life example can help you to understand the concept of and or. So here I just give you the example here. So if you still cannot understand why true and true or true or true is true or false, something like that, I would recommend you to type this program by yourself and then observe the output here and truly understand what is the meaning of each expression. Then I believe you can understand the concept of logical operator. And one thing is important is that logical operator will actually treat any non-zero operand as true and any zero operand as false. So if we put negation operators in front of 2, because 2 is a non-zero value, right? So the negation operator will consider 2 is true. So that is why the output of negation 2 will be 0 because it will turn true to false. And only 0 can represent false. And again, for the precedence of these two logical operators and or, their precedence is lower than the relational and equality operator, and they have left associative. So if we have the example here, we have all these integer variable here, and we write down the line like this. And I forgot to add a semicolon here again, sorry about that. So if we have the statement like this, then we know that this is a logical operator, and the precedence of logical operator is lower than relational and equality operator. So that is why the sub-expression of these two sub-expression will be evaluated first, and then we will evaluate the logical and after we finish evaluation of these two sub-expression. So in this case, let's just check out the return value of this one. So I is 0 here, j is 1 here, 0 less j is true. So the return value here is 1. And we have the other sub-expression to check if k is equal to n, and 2 is definitely not equal to 3. So the return value of this sub-expression will be 0. And so we have 1 and 0 here, and 1 and 0 will be 0 because true and false will be false. So that is why the return value of this entire expression is false. And you can use the same strategies to understand, to calculate the return value of the second expression, the second statement. So I will leave this for you guys to try to think about that and try to think about what is the return value of the second line. Okay, finally, let's take some break. So please come back here after 4 minutes.